Hey guys! Welcome back to my channel. If you like my videos, please like and subscribe. Today we're going to be learning about direct variation. Let's get started. So direct variation is basically when there's an equation that is y is equal to kx, making it so that y varies directly with x. So basically what this means is that the equation has a y-intercept of 0. So there's no extra number being added on to the end of it. This makes it so that y is equal directly to x or to some number times x. So basically a non-example of dv or direct variation would be y is equal to mx plus b. This is a non-example because if you look over here, there are two variables in this other than x and y. So we have x and y, and then along with x and y, we also have m and we have b. So we have two variables other than x and y. So that's going to make it a non-direct variation. Over here, m represents the slope and b represents the y-intercept. So an example of direct variation, or dv again, would be like y is equal to kx. Because over here, this has one variable other than x and y. So the one variable it has is k right here. And over here, k represents the slope instead of m representing the slope like it was in the previous one. And if you notice here, there's no y-intercept, which is why it makes it a direct variation. So in this direct variation equation, the y-intercept would be 0. So that's why it's a direct variation equation. So anytime a linear equation has a y-intercept of 0, it is going to be a direct variation equation. Now that we've sort of looked at what direct variation is, let's look at direct variation on graphs. So with direct variation on graphs, there are two basics that you need to know. The first is that they're always going to be shown as like straight lines. It's never going to be like a curve or a parabola or a exponential equation or a exponential graph. It's always going to be a completely straight line. The second one is that they always pass through the origin, or 0, 0 on the graph. This is because the y-intercept of direct variations are always 0, so it's always going to have to pass through the origin to be considered as a direct variation equation. So I'm going to show you guys some examples. So a non-example of a direct variation equation would be something that was on a graph and looked like this. This is because, first of all, this isn't a straight line, it's a curved line. It follows a curve. And second of all, it doesn't pass through the origin, or 0, 0. If you look, it has a y-intercept right there. So this would be a non-example of direct variation. A real example of direct variation would be something like this. This is direct variation because it is a completely straight line and because it passes through the origin right here, the origin 0, 0. So this will be an example of a direct variation equation on a graph. Now that we've seen what direct variation looks on graphs, let's see what direct variation looks like on equations. So, like in the graphical part, equations also have two basic components in direct variation. The first one is that they will always be linear equations. They will never be a quadratic or an exponential or any other type of equation. It is always going to be a linear equation. The second aspect of it is that the y-intercept will always be 0, and so it's not going to be shown in the equation. So again, I'm going to show you guys some examples. So first I'm going to show you guys a non-direct variation example. So that would be something like y is equal to 3x minus 4. So this is because while it does tick off as being a linear equation, which will end up giving us a straight line, the y-intercept of this is not 0, because if you recall, the last number in a linear equation is going to be the y-intercept. So the last number over here is -4, but in a direct variation equation, it shouldn't even be shown. So because of this -4 right here, this is not a direct variation example. So an actual direct variation example would be something like y is equal to 3x, because this still checks out as being a linear equation, because it will end up giving us a straight line. And over here, the y-intercept, you can tell, is 0, because the actual y-intercept component of it, like an actual number at the end of it, isn't shown. So you can assume that the y-intercept is 0. So this would be a direct variation example. So now that we've seen what direct variation is and look at what it looks like in graphs and in equations, let's move on to the next page to do some practice problems. So we have our practice problems, and let's go to problem number 1 and fill out the table. So in our table, we have not dv or direct variation, and we have dv or direct variation. So in direct variation, the line has to pass through the origins, or 0, 0. But in not direct variation, that doesn't apply. It doesn't have to pass through the origin. Now in not direct variation, it doesn't have to be linear or a straight line, but in direct variation, it has to be a linear or a straight line. In direct variation, there is one variable other than x and y because it doesn't include the y-intercept, because in an equation, you can't see the y-intercept since it's 0. But in non-direct variation, it will have two variables other than x or y, because it will have a y-intercept. Now, using this table and having it filled out, let's move on to problem number 2. So problem number 2 says determine whether or not the following equations are examples of direct variation. If so, find the constant k. So the first thing we're going to want to do is solve these equations for y, and you'll see why we do that in a minute. So I'm going to start solving the first one, and if you guys need a review on solving equations, you can go check out my previous video. So our final solved equation for this one is y is equal to 6x. Now, if you recall, we had two different types of equations. For direct variation, we had y is equal to kx, where k is the slope. And for linear, not direct variation equations, we have y is equal to mx plus b. So basically, once we solve one of these equations for y, we want to see if it resembles the first equation, the direct variation equation, or the second one, which is the linear non-direct variation equation. So in the first equation, k is equal to slope, and in the second equation, m is equal to slope. The only difference between the two is that there are different variables for slope, and that in the non-direct variation equation, we have a plus b here, which indicates that there's going to be a y-intercept that's not 0. Whereas in the direct variation equation, the y-intercept is just 0, so it's not shown in the equation. So looking at these two, y is equal to 6x most closely resembles the first one, which was the direct variation equation, because it doesn't have that plus b at the end. And so what I can say about this is that since y is equal to 6x and it resembles the direct variation equation, this is an example of direct variation. So yes, this is an example of direct variation. It also tells us to find the constant k if it is a direct variation equation. Remember, in direct variation, k is just the slope, and so if we look at the equation over here, 6 is in front of the x. So that means 6 is our slope. So k is going to be equal to 6. And so that is our answer for our first one. So using the same method, we are going to solve the rest of ours. So let's move on to the next problem. So problem number 2, we're just again going to solve for y. So our final equation solved for y in this scenario is y is equal to x plus 1. So if we look at this, it has a plus 1 at the end, which signifies that the y-intercept is 1. So no, this is not a direct variation equation. And since it is not a direct variation equation, it will not have a k value. So I'm going to start solving for y for our next one over here. So now looking at this, you can tell the y-intercept is 0 because it doesn't have a b value. So we're going to say that yes, this is a direct variation equation, and the number in front of the x is 3 over 7, so k is equal to 3 over 7. And that is our answer for this one. Now that we've practiced direct variation equations, let's move on and look at direct variation graphs. So problem number 3 says determine whether or not the following graphs are examples of direct variation. If so, write the equation for the line. So if you remember the conditions for direct variations on graphs, it's that 1, it has to pass through the origin, and 2, it has to be a completely straight line. So looking at our first one, we can see that it passes through the origin. But if we look at it, the shape of the graph is a parabola and it is not straight. So since it doesn't meet both requirements, we can say that no, it is not a direct variation graph. So for our next one, we can see that this one does pass through the origin, and it is also a straight line. So because it meets both of the conditions, we can say that yes, this is a direct variation line. And it says that if it is direct variation, we also need to write the equation for the line. So to find the equation for the line, all we have to do is just find the slope. So remember, for finding slope, first you choose 2 points on the graph. And so I'm going to choose 0, 0, and I'm going to choose 1, 4. So for slope, remember, it's rise from one point and then run to get to the other point. So to get from one point to the other, we rise 4. So 4, and that's going to be over the amount we run from 4 to get to there. So we rose 4, and now we're going to run 1 to the right to get to that point. So 4 over 1 is our slope, which can simplify to 4. So our equation for the graph is going to be y is equal to 4x. And that is going to be the answer for this one. For our next one, this one also passes through the origin, and it is also a straight line. And so because it meets these two conditions, this is considered a direct variation graph. And to remember, we have to find the equation for the line. So I'm going to choose 2 points on here again, which is going to be 0, 0. And I'm going to choose -4, 2. So for finding the slope on the graph, I'm going to rise 2 from 0, 0, so that's going to be 2, over how much I run from 2 to get to the next point. So I run 1, 2, 3, 4. So I run -4. Since I'm running to the left, it's going to be negative. So it's going to be 2 over -4, which can simplify to -1 over 2. So then our final answer, we're just going to plug in -1 over 2 in for k for the direct variation equation. And our final answer is going to be y is equal to -1 over 2x. And that is going to be our answer for this one right here. So that's it for today, guys. I hope everything made sense. If you want more videos, please like and subscribe. Be sure to comment any questions you have in the comment section below, or to comment any other topic ideas you want me to cover. Also, be sure to follow me on Facebook and on Instagram from the description below. Thanks for watching. See you next time. Bye!